The first part of 10.1 deals with vocabulary words. The first vocabulary word is a circle. A circle is a collection of points that is equidistant from a center point. The notation for a circle is a circle with a point in the middle. So if I want to name this circle, it's going to be circle P. We also have circle Q and circle R. Now the center of a circle is a point. So if I want to name the center of circle P, I'm going to use the notation for a point, a capital letter P. And the center of circle Q is capital letter point Q, and the center of circle R is capital letter point R. The radius of a circle is a line segment that connects the center of a circle to the point on the circle. So segment QE is a radius. The notation for a radius is the notation for a line segment. A chord is a line segment that connects 2 points on the circle. So if I look, AF is a chord. The notation for a chord is going to be a line segment. Now the diameter of a circle is a very specific chord. It's a chord that goes through the center of a circle. So if we look, LJ is a diameter. It goes from point L to J, connecting 2 points on the circle, but also hits the diameter, or also hits the center. The notation for a diameter is a line segment. Now a secant is a chord that is turned into a line. If I extended segment AF and made AF into a line, I'd have a secant. In this picture, I have a secant right here, from M to K, and all the points past M, and all the points past K. The notation for a secant is a line, because I want to include the points past M and past K. Now I can take a secant and I can turn a secant into a chord by not including these extra points. So if I just said segment MK, I would have a chord. Now last chapter, in chapter 7, when we talked about tangent, we talked about opposite over adjacent. In this chapter, tangent means touches at one point. So in this diagram, we have some tangent lines. If we look at line DT, DT is tangent to circle Q. It touches circle Q at exactly 1 point. Different than a secant, which touches at 2 points, DT only touches once. So a tangent line is going to be DT. The point of tangency is that 1 point of intersection between the circle and the line. In this case, it's going to be capital letter point D. Common tangent. A common tangent is a specific tangent line. It's a tangent line that is tangent to 2 circles. So if we look, we have circle P and circle Q, and line BC is tangent to both P and Q. So a common tangent would be BC. And this common tangent is on the outside of both of those circles. So this is a common external tangent. HI is also a tangent. It touches 2 circles at 1 point, but this time it's between the 2 circles. So HI is a internal tangent. Well, if we look, B and C and H and I are also points of tangency. And the notation for a point is just a capital letter. So I'm going to add a couple more points to my points of tangency. I also have a point right here, O. O is the point of tangency between these 2 circles. This point is the one point of intersection between these two circles, so it's a point of tangency also. Let's look at a couple theorems from section 10.1. The first theorem says if we have a line of tangency, that line of tangency is going to have a point of tangency, and if I connect the radius from the center of the circle to that point of tangency, it's going to create a perpendicular line. That's theorem 10.1. Now we can use theorem 10.1 to make theorem 10.2. If I have two lines of tangency from S to R and from S to T, I can connect the two radiuses P to R and P to T, and both of those radiuses will be perpendicular to the lines of tangency. And since PR and PT are radiuses, and all radiuses are going to be congruent to each other, I can mark PR congruent to PT. And if I draw in the line segment SP, I create two triangles. And since both of those triangles share that common side, these two triangles are going to be congruent to each other by HL. HL. And since these two triangles are congruent to each other, all of their parts are going to be congruent. So segment RS will be congruent to segment TS, which is exactly what theorem 10.2 says. If we have a tangent segment from one single point, those two segments will be congruent to each other. SR is congruent to ST.